Hi, I'll show you how to build a software-defined network in the Bigswitch lab. As you can see here, we have 9 switches and 1 controller and 4 servers. The lab comes with the leaf groups R1, R2 and R3 already defined. A leaf group is 2 switches appearing as one. And from the leaf groups, we'll define port channels to the servers. Port channel R1, H1, R1, H2, R2, H1, and R2, H2. And I'm using port 5 and port 6 in this setup. Once this is done, it will look like this, and I will only do configuration from the controller to basically to the cloud, and only be using the port channels out from the cloud. I will be logging in via CLI as well as GUI, and I'll show that is only one configuration file. So let's get started. I'll log in via the CLI, and I will also log in via the controller GUI. And then what you will see is that there is only one configuration file. And very important to understand as well as when the switches are delivered and installed, they are just plugged in to the same network as a controller, and the controller will download the switch images to the switches, and everything will be up and running. And the switches will find each other using LLDP. So this is a GUI, and what I will do is that I will configure the port groups to the servers. Port group R1, H1, and now we're using static port channels as you see, but those can of course be dynamic as well. And it's port 5 on the 2 switches that are connecting to the server 1. Doing the same step to server 2. And the same thing, servers 3 on leaf group R2 this time. All this can of course be done using CLI as well. I will soon show you how the configuration will look. So we have all the port groups in place, and we do a show run. And you see that the port groups are defined. The port channels to the servers are up. So now it's time to do some software-defined configuration. I will create a tenant. That's basically a VRF when you work with the physical switches. And I will create the segment IT and the segment finance on the tenant Dell. The segment is more or less a VLAN in the physical world, but the VLAN can be reused. So you can have different VLANs used on one segment, and you can have the same VLAN on different segments coming in to the cloud from the servers. So let's see how this looks. Okay, time to start to configure. I will create a tenant, del, save that one, and now I will create the segments, the segment IT and segment finance. And as I said, that's a VLANs in the normal switch world. Okay, let's create this segment del IT, and I have to connect the port channel, or when I created del IT and del finance, I have to connect the port channels and say that the incoming port channels, incoming traffic on these port channels, specific port channels, should belong to IT or finance. And you see that it's untagged traffic, but it can of course be tagged traffic and the same VLAN for different segments as long as the physical ports are different. I'm going in on del IT, and as you may recall, we have two servers connected to del IT, and then of course two different port channels, or port groups as they are called here. So now we have connected the segment. I'm connecting to the CLI on the server because I now have connected two servers on the same segment. And I'll try to ping from one server to the other. One server is .2 and the other .3. And as you see here, I haven't done anything more than connecting the segment to the port channel, port group. I also try to ping to the other segment, to the server on the finance segment, and also I'll connect to that server and try to ping to segment IT, a server on segment IT. And as you can see, that doesn't work either. It's not a surprise that it doesn't work. And why is it so? Well, of course, we haven't created a router yet. So we'll create a virtual router to connect traffic between the tenants. And as you can see, we have a tenant del in the configuration file, and we have segments finance and the segment IT, and we've connected VLANs. So let's go on, connect to the tenant and create a tenant router. And the first thing I have to do then is to create an IP interface for each segment. So it's basically the default gateway that I'm creating at this moment. And it's .1 on the two different segments. Del Finance, you may recall that it was 10.0.1 network. So I've created a default gateway and created the IP interfaces for the two different segments. So let's see how this works. And it works fine, as you can see. Now we can route between the segments in the tenant del. And I'll also show you how you could troubleshoot this. I do a test path. I choose a source IP address, an endpoint, and I choose a destination endpoint, and then I simulate the traffic. And what you will see here is that the traffic will go from the finance segment, tenant L, and to the IT segment. And you will also see the physical switches that the traffic will pass. So now I've done that, and you can also see how easy it is to troubleshoot, and we'll take the next step. We'll create another tenant, a tenant Volvo, and we'll create a tenant router, and we'll see if we can send traffic between them. And to do that, we also have the traffic has to pass a system tenant router, which is basically the interconnect point between the different tenants. We'll do exactly the same steps as we've done before. We'll create the tenant Volvo, and on the tenant Volvo, we'll create the logical segments. And while I'm doing this, you have to recall that when the switches were delivered, it was just plug and play. Connect the controller and connect the switches, plug in both of them so they can communicate on layer 2, and it's up and running. So we'll create the default gateway. We only have one segment here in the default gateway, 2.1. Let's log in via the CLI and see how it looks. Still only one configuration file. You can do all this via the configuration file as well. And I'll try to ping now from the server at Volvo IT. And we can be pretty sure that it will not work when I try to ping to Dell. It doesn't work. And let's troubleshoot that and see why it doesn't work. I go to endpoints. I specify my endpoint that I'm trying to ping from, Volvo. I do a test path. And I'll take the destination endpoint. I choose the one I try to ping to, Dell, and I'll simulate that traffic. And you'll see that I will not leave the tenant Volvo. Because I have to find a way out from the tenant Volvo. And to communicate with another tenant, I have to be connected to the system tenant. Let's call it an interconnect VRF. And I also have to create a default route. And in this case, I'll just say that all traffic that's not local is going to the system tenant or the common VRF. And I'll do the same on the Dell tenant. So the default route is out going to the system tenant. It can of course be a firewall or a physical appliance somewhere. And now I have to connect the two tenants to the system tenant. As long as they are not connected to the system tenant, it's not possible to send traffic between the tenants. So let's call it the interconnect VRF. So let's see if this works. I hope so, and yes, it does work. So the ping worked fine, and now we'll see how the traffic flows between the endpoints. We'll choose the endpoint at Volvo, the segment Volvo IT, and the destination endpoint, and it will be at Dell IT, and we simulate the traffic, and you will find exactly how the traffic did flow between the logical elements and also the physical elements. And we have all this in one configuration file, as I've said many times before, and this would have been done in less than 5 minutes if you are fairly experienced with a normal industry standard CLI. So pretty easy, isn't it? There is much more you can do. I've done this in probably something like 15 minutes. You can do much more. You can use ACLs, you can do policy-based routing, you can push traffic to firewalls, to load balancers, etc. So there are many things you can do. This is just a sample.